Hey everyone, and welcome to a new video. Last day I was checking a tutorial from one of my favorite YouTubers, which is called the Teen Matrix. And this tutorial is about third-person camera. So basically how to create a camera that follows a character in a 3D environment. And he does it in Java. But I've adapted this to Max, so in this video we will see how to create a camera that can follow our character, and we can turn around with the mouse and the camera will be always centered on our character and will follow it from behind. So like in a video game basically. So, without any further ado, let's start. Now first of all I'm going to create a new picture. So there it is. So first of all, I want to show you the math that we're going to use for that, which is very well explained in the video from the Teen Matrix. But basically, what we need is to calculate the offset on the X and the Z axis of the camera from the character. So the offset, we can calculate it as the distance from the camera to the character multiplied by the cosine of the angle of rotation of the character. This is for the Z offset. So to find out the X offset, we can multiply the sine of the angle by the distance of the camera from the character. Okay, so it's very simple, but if you're more curious about the math involved, I will put a link to the video of the Teen Matrix so you can check it out for yourself. Now, inside Max new patcher, we're going to create a JIT world, of course. I will call it cam follow or something. And I will give it the floating one attribute. We'll give it size 320 by 240, all the usual stuff that we always do. And then I will set it enabled by default. What else do we need? Well, maybe full scale anti-aliasing, why not? And that's it for the moment. I will create then a jit.fps GUI to keep track of the frame rate that we managed to get out of that. Okay, so now since I am on the M1 Mac, when I'm on the second screen, I have this kind of weird thing that the frame rate is always very low unless I set the synchronize attribute to 0. So now we should have a frame rate of 60, although it always so goes in conflict with OBS rendering. So the frame rate is not great, but don't worry about that. That's kind of a weird thing of the M1 Mac. So what we need to do now is to create a GGL model object. This will be the model that will be in our world. And there is a very cool model built in Max. It's called something like Dwarf. So if we go inside the file browser of Max and we search for Dwarf, yeah, there it is. It's called dwarf2.b3d. So let's go here and give it the file attribute to the GGL model called dwarf2.b3d. And there it's our dwarf. Very cool. It doesn't find the texture for the axe, unfortunately, but it doesn't matter because we're anyway going to use a GGL PBR object attached to this 3D model. So in this way, we are basically bypassing the texture of the objects. It will just have the color that we decided to have. For example, with the matte diffuse attribute of GGL PBR. Let's make it like something like pinkish, but I think we also need to set the material mode attribute of the GGL model. So if we go here and we go into material mode, we should maybe set it to 0 exactly, so it will inherit its own the color from the GGL PBR. So let's go here inside the GGL model and set the material mode to 0. Okay, let's make it a bit brighter. So let's go with something like that. Something like that. That's our character color. And cool. Now, what we want to do is to be able to move this model around. So in order to do that, we need a JIT_anim drive, of course, with UI listen, so it will listen to our keyboard input. And let's set the speed to something like 10, for example. Now, if we connect this directly so to the to our GGL model, you can see that if I move around with the mouse, the object is starting to rotate in very silly ways, and we can also push it up and down. So that's kind of silly. If we want to reset our animation, the movement we did for the model, we can send the anim reset message to JIT_anim drive, but we also need to set it to the GGL model. Okay. So what we want to do in order to avoid this rotation thing is to actually modify the input dictionary of the JIT_anim drive, or at least this is the way I found to do that. So as you can see, there is a mouse map here that says that if you move the mouse down vertically, it will move it will rotate on the x-axis. This we don't want. So what we need to do is to create a new dictionary, give it a name, anim dict or something, and also embed it with the patch with the embed1 attribute, because we want to modify this dictionary and pass it as a dictionary to the JIT_anim drive. So let's double click on the JIT_anim drive. Let's copy the built-in dictionary. Let's go inside our own dictionary, past that, and simply replace this -1 with 0. Now we close that. We saved the patch, and this is now saved into our patch. So now if we send this dictionary to the JIT_anim drive with a bang, we will not anymore be able to rotate the character on the x-axis, which is what we want. Now, another thing that I would like to avoid is for the character to kind of go vertically, to move vertically. So to do that, we need to create a JIT_anim node. I mean, we could do the same trick we did with the dictionary, but since anyway we need a JIT_anim node for our patch, I'm going to create a JIT_anim node connected between the JIT_anim drive and the GGL model. And to this JIT_anim node, I'm going to say lock plane 2. Because in this way, it's not going to move anymore vertically. So lock plane 2 will lock the y plane. So lock plane 2, lock y movement basically. So the character cannot move anymore on the y axis, which is what we want really. So that's great. So we can only move horizontally. And cool, so now I guess it's time to create our camera, because we want the camera to follow the character. So let's create a GGL camera and give it the tripod attribute 1, because we don't want the camera to tilt. And let's give it the look 1 attribute, although we don't really need that. No, okay, that's great. We just need the tripod thing. Good, so now we need at every frame to get the position of our character and pass it to the camera in order to calculate what's going to be the offset of the camera from the character. So cool, let's do that. So I'm going to create a receiver here for the metro, for the bang, the world bang basically. And I'm going to send it from the middle output of the JIT world. Cool. And I'm going to connect it to the JIT_anim node. So basically I'm going to send to the JIT_anim node the message get position. And so from the JIT_anim node at every frame we will get the position of our 3D object, our 3D model. So I'm going to root position here, connect it here, and I'm going to set it as the position of the camera. So let's do like this. These are going to be 3 float numbers. So I actually need first to unpack them, because I want to add an offset to the y so that the camera will always be a bit above the character or below, depending on how we set the offset. So this is going to be the position of the camera. So I'm going to sum a little offset to the y position. Then I'm going to pass the x as it is and the zeta as it is. So the camera is now exactly where the character is. And now the camera is a bit above the character. So we don't see anything anymore because the character is right below the camera. if you remember now here, we said that for knowing the offset, we need to multiply the cosine of the angle of rotation of the character by the distance. And for the x offset, we need to multiply the sine of this angle by the distance. So what we need to know here is the rotation of this character. So instead of always sending the get position, we're going also to send the get rotate x, y, z message to the JIT anim node. So here, if we route the message rotate x, y, z, we will get the rotation. Now we're only interested in the y rotation because the character can only rotate on the y axis. So we're going to unpack that as well. So now we need to multiply the sine of this angle and the cosine of this angle by the distance of the camera and the object. And this distance we can choose ourselves. But before doing this multiplication, we need to pass this angle, which is now in degrees and in radians, to the sine and cosine objects. So in order to convert this angle from degree to radians, we need to multiply that by pi divided by 180. So let's see, we should do something like 3.14159. This is something approximation of pi divided by 180, and this whole thing multiplied by the angle. So we can simply set this as a constant here basically, and divide pi by this angle. We could have wrote also other way around, but I chose to write with the exclamation mark division. It's the same really. So this is going now to be our angle in radians. Let's actually set a load bang here. So we can now multiply this angle by the sine and cosine. And we need to multiply this by the distance. So let's create another couple of multipliers. So we need to have a float number which will represent the distance from the camera. Okay, cool. So now here, actually to get the position of the camera, we need to subtract the offsets from the position of the character, right? Because if the character here is at 0, 0, 0, if we want to get the position of the camera here, we need to subtract the offset from the position of the character, which is 0, and then this will give us the position of the camera, for example, something like minus 0.5. In this case, since the camera is in the negative x-axis. And the same with the zeta, since the character is at 0, 0, 0, for example. If we subtract the zeta of, for example, of 6, we will have then that the zeta for the camera will then be something like minus 6 or something. Actually, the zeta is positive going in our direction, so this will probably going to be something like 6. Okay, so let's see if this works out. So we need to subtract from the position these numbers that we just calculated. So for the sine, it's going to give us the x offset. So this should be it. And the cosine is going to give us the zeta offset. And so if we make the distance a bit bigger, let's see. Okay, so this should actually work, but since the camera is looking at a position in space that is not directly related to the character, or there it is, we should actually tell to the camera to look at the character. So we can use the position of the character to use it as the lookat position of the camera. Okay, cool. So now if we did everything correctly, we should be able to look at the character, and the camera is always at the same distance and always at the same pitch toward the character. Okay, so this is cool. The only thing is that the character is inverted, and that's because we say that the positive zeta axis goes toward the screen, so we should not subtract for the z axis, we should actually sum. So I guess we can simply modify this negative into a plus, this minus into a plus, and okay, yeah, this is working. Great. Now, to have a bit kind of a sense of movement, I would like to place some objects in the screen so we know where if we are actually moving or not. So in order to do that, we can use, for example, a JIT-GL multiple. I'm going to do this fast since we did it already a lot of times in a lot of tutorials. Alright, so we got our cubes here. And let's actually connect a GGL PBR to those cubes. Right. Let's pack these into a subpatcher. So let's call these cubes. Actually give them a color, so something like red. So we can go in the PBR and change the matte diffuse again. So 1001, right? And you know what? Let's actually use also the new GGL environment object to get some sort of skybox. And then I'm going to also use a GGL skybox object with infinite set to 1 in order to have a skybox. Right? So we need to drop a file inside our GGL environment. So if we go inside the file browser, we can see that Max has already some EXR skybox files built in. One that I like is this one. So if I copy the file name, I can just, not the file path, I can just give it as a file name to this to the environment object, and boom, we have a beautiful skybox here. Now, as you can see, there is something wrong with the rotation of the character. Oh, by the way, the skybox is also being, so the environment map is also being used by all the PBR objects in the scene. That's why everything looks so good, because it's reflecting the light from this skybox. So there is something wrong here with the rotation, and that's because the JIT anim node should actually have the anim mode set to local, otherwise it's not gonna work correctly with the camera. So check this out, and in fact it's still set to parent, should actually be set to local. And also that's not enough, because what we should set also is inherit rotate set to 0, because otherwise it's going to rotate this node as well, and then this is going to play wrong with the camera. So let's see if now this works. Okay, now this is still wrong because it's not rotating correctly with the camera, so I think we should actually set this back to minus, and now I'm really just testing out in real time. Okay, so you know what fixes it? Going with the distance negatively. So instead of having a positive distance, if we have a negative distance, then it works, which I guess basically means that we have to reverse those signs here. So instead of minus, plus for both the x and the y, maybe depends from the direction of the axis in Max. Compared to OpenGL in the tutorial that I was watching? Maybe. I'm not sure actually. But anyway, we got it working by setting these to plus. Cool. This is basically it. One thing that you can see is that this is actually stuttering. And that's because the position and rotation are passed to this little algorithm here. After the object has actually changed already position, so the camera gets updated basically one frame later. So this is not what we want. So what we want then is to first pass these messages to the camera and then bang the animation for the object. So what we can do is to set the JIT anim node to automatic 0, and then what we want to do is to first pass the messages to the camera and then bang the JIT anim object. Okay, and this gives us a very smooth and nice animation. Great, so that's what we want to do. We could do this whole thing in JavaScript using a jitter listener object. This will spare us the fetching of the position and rotation at every frame. This will do it automatically, the jitter listener. Maybe we will do that in a further tutorial. So for the moment, that's it. We can maybe reduce a bit the ease of the JIT anim drive, so set it like something like 0.2. And we should actually also load bang this dictionary inside the JIT anim drive. Yeah, forgot to. After I reset, I changed the JIT anim drive, remember to always set the dictionary back, and also the JIT anim node went back to parent mode, which is wrong, so it must be local. It really wants to go back to parent mode for some reason. But okay, we got it. One bonus thing is that we can animate this GL model. So if we send to that the anim enable message, we can animate the model, start its animation or stop it. And what I did in my demo video in the beginning is that I looped only the part in which the character is running, and I use them when we press W, and when W goes up, the character will stay still. And if you're curious about the loop animation of this 3D model, there is an example in Max here. If you go into jitter example, render model, a model anim loop will show you how this character is, the animation of his character, how to loop animations in general, which is really cool. I actually encourage you to check out all the examples in the examples folder, because it's really full of gems, and if you haven't yet, you should definitely check that out. Set cubes, okay, we got the load bang, we got everything set up, and cool. I think this is it. We now created a nice camera following our main character, player character or something. This could be something like in a little video game, or for everything you want to use it. So great, thank you for following. If you would like to download the patch that I showed you in the beginning, the demo patch, this I uploaded in my Patreon, so you can get it by supporting the channel. And also by joining the Patreon, you will also get access to the Discord community and join more than 400 patrons that are already there. But in any case, thanks again, and I will see you in the next video. Have fun. Ciao.